everyone for the talk from Bob Voorneveld about implementing Gmail API in the CRM system. I was requested to say that it was not just Gmail. From the description it seems also there's something about angularjs there, Django, Elasticsearch. Well, let me just get out of the way. Give it up for Bob Voorneveld.
Hi, I'm Bob Voorneveld, 30 years old, working for Spindle, our company logo. Professional developer for 1.5 years now at Spindle, and primarily we're working on a CRM system and not instead of my clicker. Yeah, not on a CMS system. So for everybody who thought I was building a new CMS system, that's not correct. We're building a CRM system, so let's correct that. CRM means customer relationship management. So it's a place where we store every communication that a company has with his customers. We built the Gmail API into our CRM. So that's what I'm going to talk about. As was announced, I'm not only going to talk about the Gmail API, because the Gmail API at itself is pretty easy and simple, but it's the whole development stack that we use to integrate the Gmail API into our website. So who are we? We started as a company that's called Voice, that does voice over IP. It's about 9 years old now. The developers who started in Voice ended up in VoIP, who's what is actually building the platform that Voice uses, and all the developers are pulled out of that company by the 1st of January, and we're now in Spindle that develops multiple programs, which is VoIP and Hello Lily at the moment, and probably in the future a lot of more people. So this is probably the biggest part of our team. We started out with 8 people. I was the 8th person coming in January last year. We're now with 30 people, so we're growing big, and we're still hiring. So if you want to join us, please contact us. So why did we build another CRM? There are many CRMs in the world, but we lacked the simplicity, and the communication should be central in the CRM, and that's something that we lacked in all the programs we tried. And I asked our founder to give a good extra point out to what our CRM should be special about. So communication should be the central point. That's what I said. And it needs to eliminate human input. A lot of CRMs that we tried meant that you had to make notes about everything. So you as a company, the person who works at the company, has been in contact with someone through email, through the telephone, or Twitter, or whatever, and you had to make a note out of it and put it in the system. And that is that gives you problems, because if you forget to note down what kind of communication you had with the customer, the next colleague will not see your notes. So we try to automate that communication part. And a big communication part of the companies that we work at is email. We email a lot with our customers, so email is a big part of our system. Hello Lily is the name of the product that we're building. Hello Lily should be, you should be able to imagine that it's a girl who's your secretary and does all the work for you, so you don't have to do all the obligated stuff that is needed to set up the information. And she should be a bit funny, nerdy, and very smart, so that you don't have to do anything to get the information running. And we try to keep it simple. Lots of CRMs have lots of different possibilities to plug in. We keep it simple. You have accounts that are companies that you're contacted with, contacts. Most of the times those contacts work at one of the accounts that you have. And then we keep it simple. Some of the customers you have a problem. They communicate to you that they have the problem. They create a case, and you try to resolve the case and give feedback. And the other one is creating a deal. Just you make a deal of you put sorry,
Quote.
a quote. It's not the part I've been working on a lot. You create a quote, you send it off to the customer, and you can do that in your own system. It's not something that we're building. You have your own quote system, but you keep track of the quote, and in the deal section is the part where we track what the information and the status about your quote is. And we have a full integration, or we're trying to build a full integration of your email system. And that's what I'm going to focus now on. One of the things that we're going to build in the future is phone calls, automatic tracking of phone calls. We started off as a phone company. We do a lot with voice over IP. It's very easy for us to put information about a phone call into the system, so that's something that we're going to integrate, so that if someone calls you, we make a note directly out of it. And way more in the future, we're going to integrate Twitter and whatever is with that account. We try to do it with IMAP. IMAP is the standard for email at the moment, next to POP, but I'm not going to talk about POP at all. But we tried to implement IMAP, and this was sort of my quote in October. IMAP is a bitch, let's switch to the new Gmail API. I was reading about it on the internet that Gmail said, well, IMAP was good for what it was, but the last change in the IMAP protocol is in '98, so let's change it. We're going to build a Gmail API so that you can access our inboxes completely. So I was brave enough to say, let's switch over. It's going to help us. We're all in the Google Apps for Business, so we're all having Gmail integration. Let's switch. But before I talk about what problems we had, let's give a quick overview of our implementation. We're running on Heroku. We have an app there that's built on Python 2.7. Still a lot of pip packages that are not compatible for Python 3, so we're sticking to Python 2.7 at the moment. We're trying to keep up with Django. We're now at 1.7. We'll probably switch over to 1.8 as soon as someone has some time left in his schedule to see if there are big changes, but I don't think there are many big changes, so we'll pop that up to 1.8 pretty soon. Django REST is our API framework connected to Django. Django pipeline, Zaal3, IMAP, Progress is our database, Elasticsearch search engine, and we're building now on a almost complete from the end single page app. That's Angular 1.3. And we're trying to keep up with that as well. When Angular 1.4 comes out, we'll try to switch over as soon as possible. And we'll do some monitoring as well on log entries and leave cloud. Why those two? Those two are pretty nicely integrated in Heroku. So that's something we don't have to do a lot of effort for it to do some monitoring. Heroku. At the moment it's still a pretty small app. Our own company is using it with about 60 people at the moment. Heroku uses dynos. One of the instances sort of Docker-like. I'm still not sure what it actually is, but it runs off as a single container, completely isolated from the rest. We use 2 web dynos because that's the standard on Heroku. If you want to have an active app for the whole day, you need 2 dynos. And we use 1 gigabyte of memory, so the standard one is 512 MB. This is 1 gigabyte. A beep dyno that's doing nothing more than sending a signal to Zaal3 to do their tasks. And 2 workers who are running all the asynchronous work in the background. Pros, it's very easy to deploy. You do a git push, and for us we need to do some static collection and indexing as well, but that's it. You can deploy a lot, often, and very easy. Very big pro is also there's no maintenance, in that you don't have to keep up your servers and what all. That's something that Heroku does. It's very scalable. If you're, well, let's say we get a lot more email accounts in, and the worker who's doing the synchronization is being busy too much. We just start off a new worker and we can run more, so you don't have to buy a new server or anything. I'm not going to talk about the cons, there are a lot of cons about it, but I just like to keep it positive, so only pros. Sorry, critical questions you can do afterwards, but I'm not an expert on everything, so just pros. Django 1.7, we use it less and less every time we switch more to the front end app with Angular 1.3. We still use it for the anonymous views. So if you're landing on the app page, the first page you see is an anonymous view for a login. That does the authentication as well. And we keep that authentication that way, so we don't have to do any major stuff in the front end. Just let Django do it. We started off as a complete Django, and we switched to Angular only a couple of months ago. This works for us, so we're keeping it that way. The rest of it, what it does is one single view it returns. It has all the templates for Angular in it. It has all the JavaScript files, the CSS files, minified and concatenated and versioned. So that serves it off, and that's what Django does, and the rest is being picked up by Django REST, just API endpoints to get our data into Angular. Zaal3, that's the asynchronous stuff. The scheduler, that's sending out a task to synchronize the email every 5 minutes. So an email box is at most 5 minutes old for getting new messages in. We have two different functions. One is doing the first synchronization. Something we didn't account for when we started this project is the big amount of emails someone could have in their mailboxes. On average, we're about 10,000 emails in a mailbox at the moment. But someone last week pushed their our knock mail, the error mails, into it. It was about 180,000 emails, and that kept our worker pretty busy. So we switched that off to a different worker, and the incremental synchronization is being done as well in that worker. So that's the one that does the every 5 minutes the checking. And we have a lot of different functions for handling the email, what the user is actually doing with their email, reading it, sending it, moving it. Those are all async tasks that are being put into Zaal3 and being are handled without the user having to wait on the response for it. So the response times are pretty quick at the moment. On average, response time is about 100 milliseconds for the user, and that's all being all happening in a single page app. So pretty quick response times for going through the page. What I said about IMAP, it's really old, and we had some pretty big issues trying to use IMAP at first. Authentication was a problem because most of the authentication happens with a username and password that everybody uses, also for logging in. So we had to keep track of your username and password information that we actually don't want to have, because that's something that belongs to you and not to us. It's not easy keeping track of changes. Our final implementation before we switched to the Gmail API was to keep track of every inbox and just looping over every message to see if there was something that changed about it. Afterwards we read about it that it could be a little bit more efficient, but still it was not easy to keep track of what happened to a mailbox. No partial download for a message. Yes, there are partial downloads, but if it happens with attachments, you have to get all the attachments in at once, and if it's a big message, it can be a bit of a pain. The implementation from one IMAP server to the other changes. Someone has some protocols installed, someone doesn't have it, so you have to keep track of many different ways of implementing the IMAP protocol. And all in all, our workers were pretty busy doing nothing special, and it was not scalable. For a couple of mailboxes, we need to get an extra worker, so the costs were pretty high, and that was something that was for the long run, not something that was something that we could sell to our customers. And then we switched to Gmail API, and I will talk about it a little bit more afterwards, but one of the biggest disadvantages that we had at the same time was searching our database. We do a lot of matching with email addresses so that we can see what kind of email messages are related to what account. And the database wasn't really efficient for that. It was pretty, even with indexes and what all, it was still pretty difficult to get a good list of what email is belonging to what account. And we want to do that all the time in real time and not by receiving the email message, because if someone changes the email address on the account, you have to look through all the email messages. It was something that we decided we wanted to do real time all the time. So no matching on IDs or anything, but on real time searching. Problems with that was that our email model, and quite some other models that we had as well, were spread over many tables, many relations, and that meant that you had to search on one table, indexing, and then you only, in the end, came to one email model, and that made searching very slow. With every email you put in, the search time increased, and partial matching was pretty difficult. Something that we do now is when you start typing a name, we'll try to find an email address, and that's something that's in a database pretty difficult to do in the correct way. So our final solution was build a search index and build a Gmail API. At first, the Gmail API is very easy. There's a big package by Google that helps you out a lot to create the whole API. So it's just function calls to get your information. You don't have to do anything special with sending JSON yourself. That's something that the pip package handles for you. The biggest advantage of the Gmail API is that it keeps track of messages. It does so by a history. So you can ask a history from Gmail with an integer that you kept from the sync before. Let's say the last time I did a sync, I got a history ID of 100. Next time I asked Google, my last sync was at 100. How far are you now? Gmail talks to me back and says, well, I'm at 105 at the moment, and these messages are added, these messages are removed, and these messages were labels added, and what else. And then you just use every message ID to get the information about the message itself. So you don't have to scan every mailbox anymore about changes. You just ask Google, and Google gives you a nice diff of what changed in your mailbox. Very big advantage is the partial download. Google decides how big the data is that you're getting from them, and if the data is big, like there are a couple of attachments with even a couple of kilobytes too big, Google decides to give an extra endpoint to the attachment, so you can grab the attachment in an article, and that keeps your memory very low. If you're doing a lot of work with high concurrency, you can keep a low memory footprint and do a lot of syncing. So that was a big advantage. And what I just told you, since February, and that's something that we're not using at the moment. At the moment, we're getting just the message IDs, and we're checking what was changed by checking what labels there are on the message at the moment. Gmail will tell you, since February, this message is really new. So not only an ID, but also the action that was happening on the message. Something that we didn't implement at the moment, because if we screw up the synchronization in any way, we just want to fetch the whole information again. Big disadvantage, that's something I will mention, it's only for your email accounts that are connected with the Gmail API, and that's, for us, it's Google Apps for Business or your personal Gmail address. So you're limited to your customers that have switched their email to Gmail. Postgres, we found a solution by implementing Elasticsearch as well. So we're keeping Postgres as a primary data source. We put all our information into Postgres, but we're mapping everything to documents in Elasticsearch, and we send that off in Elasticsearch data storage, and that's all automatically done with a post save signal. So every model that has changes and has some way of relation with an email message or an account or whatever, we'll try to save the data again to Elasticsearch. And that meant searching within a click. We were kind of mind-blowing when we started implementing this. It was as fast that you were trying to, is this everything? Response times within 50 milliseconds, and it's scalable. If you're finding out that your search engine is getting slower and the response times are getting bigger, you just add some extra charge and search will speed up again. Difficulties, yes, we had a lot of difficulties switching. The quote was from October, we're now in May already. The first problem that we're at, and we're still not done, we're almost done. We did a big deploy yesterday. I had to do some hot fixes this morning to keep everything running again. The first problems we had was encoding and decoding messages. Everybody's sending shit over the email. They say it's some sort of encoding, but it isn't, and Google will not figure it out for you. You have to do it yourself. That's a big problem. So it took me a while. I used about 80 mailboxes and just scan it, and as soon as I found an error, just check that email, and it was some Russian guy trying to marry me. And by that, trying to replicate the message in a good way. Sending email wasn't happening at the start. You try to send it to the API, but you have to make sure the email is correct. Forwarding email had a bit to do with the way we were actually in the front end and Django trying to send messages away. Biggest problem was messages with attachments. How do you keep track of the attachments that are already on the message and the extra attachments, and try to send that away was a big problem. And then all of a sudden, messages were still in the database, but they were not in the inbox anymore. They were all archived, all in all mail, but they were not in the correct labels anymore. Happened to me. With the sync, I didn't remove the labels of the message, but I actually removed all the labels. So no message had any label anymore, and with partial sync, the labels came back again, but the matching with so a big problem, fixed it, thanks to Marco who found it. High memory usage, still don't know why that is happening, not in the workers, but on web. Has to do something again with the attachments. Our solution for the moment was to scale up the workers with bigger memory, and that helped for the moment, so it's something that we still need to find out. And sending big messages, we did a new release yesterday, and we really found out that Gmail API isn't accepting big messages at the standard endpoint. You need to use another endpoint for big messages, which you can send messages in chunks. And the Google pip package has that actually, but it isn't documented. So we found it out yesterday that you had to send it a little bit different, and now it's sending all our messages in chunks, and it works like a charm. For as far as I know, I haven't looked at any emails at the moment. So something that we're figuring out. Somewhere along the way in April, with all the problems we had, our team said, Gmail API is a bitch, let's switch back to IMAP, because we're not getting anywhere, but we're almost there. I don't know how much time do you have?
5 minutes.
5 minutes, okay. I'm trying, I'll just click through some, to my dev machine to show you how the product actually looks. And maybe if someone has questions, just raise your hand and I'll try to answer the questions. So here we go. Okay, didn't figure this out that I had to do maneuvering on that screen while I have my laptop here. So this is our dashboard. So I actually logged in already, so I'm not going to show you that, but in the session is now the Django session stored, and that's being used by every API call we're doing. In that way you just keep logged in. The dashboard is empty at the moment because I have a small data set at my local host at the moment, but for a team, the dashboard is a very good way to track everything that's happening about deals, emails, and cases, so that you don't have to scroll through every menu. You have just one dashboard that has all the information on it. And the big part, email, you can see the quick response times. I'm a bit cheating now because I'm using localhost, but still there's not a lot of differences at the live environment. What you see here is a lot of API calls going on. It's getting all my accounts that I have set up, and here it's pulling every information in from that account, every email, and it does it by pagination. You see small icons here, the green ones. That's actually an API call for every icon to check if we have information about the one who's sending you the information. So at the moment I've got as a test, Ferdy, thank you Ferdy, I added you to an account, so we know Ferdy is one of the guys that we have an account for, and the end goal, and some of our colleagues are really trying to help that, to receive that goal, is to get every icon needs to be green arrow, so everybody of the green checkbox, so you know that you have everybody registered. Just to do simple searching. That's how quickly it goes. You just remove, and you see how quickly it responds. The response is changing. One of the views that was the biggest problem for us. This is an account detail page. Again, all many different API calls. And the biggest difficulty before we went to a single page app was this. We call it a history list. This is the live matching of emails by the email that we have with the account. So I've got an email account here that's hello@wearespindle.com, and also Ferdy, his emails are being tracked as well. So you can see here's some information about Ferdy. The right side is information coming in. The left side is information coming in. Right side is what we're sending to the customer, so that we can track everything. And you can add nodes and deals. All that information ends up here as well. With Elasticsearch, it only takes a couple of milliseconds. And before we had difficulties with big accounts with many email addresses that it wasn't rendering in 30 seconds. So big difference. I think that's about it. If you want more information, you can talk to me. I lost my presentation. Oh, I thought this so good. Maybe it's questions. Oh man, it's back. Questions. Very hard to do this way, but oh yeah, the whole project is open source. So if you want to see how we implemented it, just check out github.com/hellolily. All our source code is online. It's still very agile. We're not even in beta at the moment. We're testing it out ourselves. We'll try to release somewhere during this year public beta and try to invite other companies to help as well. But our own colleagues are used to things getting broke, and beta testers aren't. So we're still waiting for that. Questions? Yeah.
How does it perform on mobile? Because you use Angular, so it's
Yeah. How does it? A good question. We decided for the moment. The question is it? How does it perform on mobile? The first initial call is the biggest one because we're downloading every template that there is. The biggest advantage of that is that it's being cached, and by then it's only data that's being transferred in JSON. So that's very small. So we're still we don't have a big enough test panel to see if that works. We can do partial template loading as well. Angular has support for that. We decided to get every template out at the start and do no partial downloading, just to improve the performance on mobile, we think, but maybe in the future we'll switch that out again. I think that's about it.